and share this innovation with you.
Just left or right?
Right side.
Right side, okay, great.
Thank you.
Okay, good morning, folks. My name is Steve Buchberger. I'm on the faculty at the College of Engineering here at the University of Cincinnati. And I want to talk to you about the water demand calculator, which is a tool for building a better building. So all across the planet today, there are thousands of engineers that are working on the next generation of buildings. And you would probably be quite dismayed to discover that they were using technology from the 1940s to design the phone system, right? Well, you know, I'm just pulling your leg on that. Turns out that's not the case. They're using, of course, the latest technology. However, the engineers that are designing the premise plumbing systems are indeed using technology from the 1940s to size premise plumbing in buildings. And in this particular case, it's something that's known as Hunter's curve, and it provides an estimate of the peak water demand, the single most important parameter for estimating or designing the premise plumbing system in a building. So it turns out this, whoops. I'm not sure what I did there.
Okay.
Okay.
We'll just give it a moment.
Okay. Sorry, a little technical glitch there. Yeah. Okay. So I hadn't turned my head. Have you seen that slide already? Okay, great. Yeah. So that's the Hunter's curve, which provides an estimate of the peak water demand in a building, the single probably most important parameter that we have. Hunter's curve has been adopted by all the state plumbing agencies from coast to coast, and in fact, it's been adopted by most countries across the planet too. But what are the consequences of using a technology that's pre-World War II in the 21st century? And I've identified about a half a dozen issues here. Of course, we have grossly oversized premise plumbing systems. We have meters that may not be able to accurately monitor water use. We have excessive dwell time. That's the time that the water sits in the pipes before it's used. We have wasted water. We have wasted energy, potential health, water quality health issues, and of course, inflated construction costs. So an entire myriad of issues associated with using this outdated technology. I'm happy to tell you that our water demand calculator will solve all those problems. The water demand calculator is based on research conducted at the University of Cincinnati for the last 10 years. We're ready to bring it to market, and it represents the most significant innovation in premise plumbing design for the last 80 years. So our value proposition is that the water demand calculator is the one and only digital design tool that provides a code-approved estimate of the peak water demand for buildings that can be made available to the A&E community to allow them to design and build better buildings. Now, what about market opportunities? It turns out we're looking at something called MEP, that's the mechanical, electrical, and plumbing sector of the building industry. On a global basis, there's about $1.4 billion of activity in that sector. In the US alone, there's about $370 million of activity in that particular sector. Our business model that we're going to roll out involves two phases. We're already in phase one, where we're looking at the residential sector. We have a web-based platform that will allow a monthly subscription, and we expect to have that available in about 2 or 3 months. Then we're going to merge or migrate toward a commercial-based water demand calculator that will be available through a Revit platform on Autodesk, and we're hoping to have annual subscription basis there, roll that out in about 2024, about a year down the road. From a competition point of view, we don't see anybody else in this space. We're not aware of anyone else that's achieved what we've achieved and can do what we can do with this particular product. Now, just to illustrate some of the great advantages that we have if we adopt our new water demand calculator as opposed to the old existing code, I'm going to just share with you a couple of metrics. Suppose we're looking at a building complex with 100 units, and we use the old method. It would tell us that we have a design discharge 400 gallons per minute. The water demand calculator says, no, we don't need that much. We can get down to 80 gallons a minute. The size of the pipe would be reduced from a 5-inch service line to a 2-inch service line. I won't talk about the volumes. That's not really important right now. But the dwell time, and dwell time is really a surrogate measure for water quality. You want to minimize dwell time. In an instance where the dwell time might be an hour, the dwell time in our case would reduce to 10 minutes. And of course, the cost goes way down. We would have a reduction in cost from about $1,500 per linear foot for the old method design to about $250 per linear foot for our proposed water demand calculator. If we look at this, in fact, Stantec did this back in 2020. They did a more holistic overview of the economic impact of this water demand calculator. And according to their analysis, where they compared the existing method and our new proposed method, single-family homes could expect to save about $2,000 on average. If you get into a large multi-unit complex, it could be up to $250,000 savings on average, case like that. So the timeline, as I mentioned, we go back about 10 years. The first 5 years of that was involved in just setting up the algorithms, getting the data we needed to calibrate it, to test it, to verify it. And more recently, we've been trying to get it adopted. I'm happy to tell you it is part of the Uniform Plumbing Code now. The state of Wisconsin has adopted it. The city of Seattle has endorsed it. The American Water Works Association has endorsed it. State of California is meeting in about 2 weeks to look at it. We're very confident that they're going to endorse it too. So we think we're well on our way. Where do we need your help? Really, 3 main areas. Number one, we lack data to really push into the commercial sector right now because we've got to have water use information so that we can calibrate the model for that particular sector. We were fortunate because we had a lot of data for the residential sector. It's much more sparse, it seems, on the commercial side. So we need your help there. We also need help in trying to appropriately or properly set the price point for the subscription fees. You know, what are the proper monthly and annual fees that we should set for a subscription? And last but not least, we could use help in marketing and branding. I mean, we think we have the new gold standard in sizing premise plumbing systems across the planet. We want to get it built into the LEED certification process. How can we do that? So besides myself on this team, I have programmer extraordinaire Toritseju Omaghomi, who's here. Toju was with me at UC for many years and then recently transitioned to industry, where she's now working with IAPMO, the International Association for Plumbing and Mechanical Officials, who are helping us on this project. She's working also with Dan Cole, who is a plumbing code expert with IAPMO. So with that, thank you so much for your time and your interest, and I'm happy to try to entertain any questions.
Thank you, Stephen. I have a question for you before they get started. So what do you need help with the most from, say, somebody in this crowd?
Yeah, I think really those 3 things are maybe equally valid, but maybe the big one is so the question was, what do we need help with the most? I think it's obtaining the access to commercial data, but we do have some leads there. So if we can get some assistance in marketing and branding, and also some assistance in how we set those price points for the monthly subscription and the annual subscription. So I think they're all equal.
Yes, Gary.
Hi, 2 things. Did you go to Cincinnati Waterworks for the data collection? I think they could help you big time in how much water in and out of condominium complexes, et cetera. The other thing is you outlined the construction savings of your product, but the ongoing water demand and supply has got to be a huge number for savings as well.
No,
you might want to include that.
Yes, you're absolutely correct. And speaking of Cincinnati Waterworks, we have contacts there, but the kind of data that they have does not have enough granularity, because we need to know what's going on at the individual fixture level to properly calibrate the model. But we can use information from them to maybe back check once we have a predictive model in place. Another hand?
Yes.
Yeah, so just a recommendation, have you engaged with the District 2030 program, or are you familiar with that? That's where they have the metrics in terms of water usage, other solar usage. Have you engaged with them locally?
Right, so the question is, have we engaged with the 2030 district? I've heard of them, and it's local, is that correct, 2030? Oh, okay, yeah. So no, we haven't done that, but that's a good idea. We should follow up on that. Another question?
You present a lot of really strong value propositions, and it really seems kind of like it's all upside. And so just curious to hear your take, and the industry expert of why no one has developed anything like this, and talk about how antiquated the hunter's curve is, but why hasn't anyone else tried to solve this issue?
Yeah, I think the part of the difficulty is that the process is codified. And so it gets built into the National Building Code, and it's adopted there. And so you have to come not only with this new information that reflects current water use that's actually changed quite a bit, right, since 1992 in the Energy Policy Act, where the federal government insisted that we use water-conserving fixtures. And so it's just not been an effort at the federal level to update the building code that predates World War II. We were really the first group in conjunction with IATMO to sit down and try to bring Hunter's Curve into the 21st century.
Right. Those are minimum requirements, though, correct? So if someone is bidding on a project and they'll be the builder, then there's motivation for them to go beyond those minimums.
A minimum in what sense?
Minimum build standards for improving the water efficiency.
Right, and so the existing code, of course, is not efficient, it's costly, and so if folks adopt our approach, they would save significant economic costs.
Okay. All right. Thank you, Stephen.
Okay, thank you. Sorry, I didn't do better with you.
Welcome back.